Hi guys, today we're going to solve a sample problem in Chapter 5 of Thermodynamics and Heat Transfer, the second law of thermodynamics and entropy. The problem is, a heat engine is operating on a Carnot cycle and has a thermal efficiency of 55%. The waste heat from this engine is rejected to a nearby lake at 60 degrees Fahrenheit at a rate of 800 British thermal unit per minute. Determine the power output of the engine and the temperature of the source. The given values are temperature is equals to 60 degrees Fahrenheit, but we need to convert it into Rankine, which is equals to 520 Rankine. A heat rejected by the engine is equals to 800 British thermal unit per minute and the thermal efficiency of 55%. Since our assumption is that the Carnot heat engine operates steadily, so the rate of heat input to this heat engine is determined from the definition of thermal efficiency, expressed as thermal efficiency equals to 1 subtracted from the quotient of heat rejected by the engine over the heat supplied to the engine. Plug in the values, we have 0.55 equals to 1 minus 800 British thermal unit per minute over the amount of heat supplied to the engine. So we have 1777.78 British thermal unit per minute as our heat supplied to the engine. Then the power output of this heat engine can be determined from net work output of the engine is equals to thermal efficiency multiplied to the amount of heat supplied to the engine. Then plug in the values, we have 0.55 multiplied to 1777.78 British thermal unit per minute is equals to 977.78 British thermal unit per minute. Since we are working to power output, so we need to convert British thermal unit per minute to horsepower, in which every 1 British thermal unit per minute is equals to 0.00238 horsepower. So 977.78 British thermal unit per minute is multiplied to 0.02358 horsepower over 1 BTU per minute. Then crush out the units, we have 23.06 horsepower as our power output. For, for reversible cyclic devices, we have amount of heat supplied to the engine over heat rejected by the engine is equals to absolute temperature of high temperature reservoir over low temperature reservoir. Thus, the temperature of the source at high temperature is equals to heat supplied to the engine over heat rejected by the engine multiplied to the low temperature. Then plug in the values, we have 1777.78 British thermal unit per minute over 800 British thermal unit per minute multiplied to 520 Rankine is equals to 1155.56 Rankine as our temperature of the sources. So that's it guys. I hope you've learned something again and see you in my next video. Thank you for watching.